Yesterday we looked at factoring using greatest common factor, and today we're going to be factoring trinomials, and we're going to start looking at this phrase, my father drives a red Mustang. Today we're going to focus on these first two pieces, the M and the F, that actually stand for something that we'll look at in a second. But what we're going to be doing is factoring these trinomials that are in this format. For example, you might have one that is in the format of x squared plus 4x plus 3. And I want to factor this trinomial to where I have two polynomials in two separate parentheses. So let's talk about what the M and the F stand for my father as a part of this phrase. The M stands for that I want you to multiply the constants or the numbers that are in position A and C. So the N stands for multiplying the constants in A and C. Now you might be asking yourself, where is A and C? Well, A and C is placed in relation to these three letters. The number in front of x squared is always represented by your A. The number in front of x is always represented by your B. And the number that is by itself is just a constant is represented as C. So the first step of this process is I want you to multiply the number next to x squared, which in this case is 1, by the number or the constant that's by itself, which is 3. So 1 times 3 equals 3. That's the product. Now the F piece of this is we're going to factor out that number, the product that we just came up with, which is that 3. So by factoring, I mean I want you to take that 3 and figure out what numbers multiply together to make 3. And this one's pretty simple. Will just be 3 and 1, and those are the only two. Now what you're looking for is you want that factor, those two numbers that multiply together to make 3, you want their sum to equal B. You want the sum of those two numbers to equal B, which they do. 3 plus 1 does equal 4. So how you're going to set this up is you're going to have x plus 3, which is this number here, and then x plus 1, which is the other factor of 3. So you're just putting them in parentheses and saying plus x plus 3 and x plus 1. So let's look at one that's a little bit more difficult. This is completed. This is your answer here. On your worksheet, this is going to be number 2. So we're looking at x squared minus 7x plus 6. So again, the first step is going to be to multiply the A and the C. Well, the A in this case is 1. The C value is 6. So 1 times 6, of course, is 6. Now what you want to do is take the factoring piece and take that 6 and factor it out into all the different numbers that multiply to get 6, such as 2 and 3, or 6 and 1. I just realized that. I'll give you a chance to write all that down. So now what I want to do is add all of these factors together. 2 plus 3 is equal to 5. 6 plus 1 is equal to 7. So what I'm looking for are the two numbers that multiply together to make this constant. Now one of the issues I have here is this constant is a negative, and all the factors I've been creating here are positives. This positive 7 is not the same thing as negative 7. So I need to keep figuring out, if I multiplied a negative 6 by a negative 1, I'd get a positive 6. And if I added them together, I'd get a negative 7. And that's what I want. I want that negative 7. So the two different polynomials will be x minus 6, and it will be x minus 1. So again, whenever you're factoring out this number, this product that you get. Remember that two negatives multiply together to make a positive, but they're going to add together to make that negative. Let's do a couple more from this actual worksheet, or from this worksheet too. Let's go ahead and look at number 4. Okay, number 4 is x squared plus 10x plus 16. So again, I'm going to first multiply together the 1 and the 16. And there's a reason. I know that you probably think it's silly that we're multiplying everything by 1, but tomorrow, when we're going to be looking at actual trinomials that have a number here as the a value, it's going to be crucial that you understand this first part of this step, this concept here. So 1 times 16 is 16. Now I'm going to factor that out. So that's 16. This number I'm looking for, this b value, is a positive, so I'm going to be looking for all the positives that multiply together to make 16. 16 and 1, 4 and 4, 8 and 2. I find the sum of each one of these, 17, 8, and 16, or sorry, not 16, 10. So in this 10 is my b value. So these will be the two numbers that I will put inside of my polynomial. X plus 8 and x plus 2. And that is your final answer. So that's you factoring out x squared plus 10x plus 16. Let's go all the way down to number 26 on your worksheet. So 26 is x squared minus 6x minus 27. So again, I'll multiply together 1 times negative 27 and get negative 27. And now I want to factor out negative 27. And I'm looking for two numbers that multiply together to make negative 27 but add together to make negative 6. Now, if I want two numbers that multiply to make a negative, that means one must be positive and one must be negative. So on 27, you can think of, okay, negative 27 and positive 1, or also positive 27 and negative 1. You can also have 9 and 3, so 9 and negative 3, or negative 9 and positive 3. So let's look at all the sums of these different numbers and see if any of them give us negative 6. Negative 27 plus 1 is negative 26. 27 plus negative 1 is positive 26. 9 plus negative 3 gives me positive 6. Negative 9 plus 3 gives me negative 6. So here's that negative 6 that I was looking for. And it came from the factors of negative 9 and positive 3. So those will be the numbers that I will put in my parentheses with the x values. And that will be your final answer. Now understand, what we're doing is we're creating the polynomials that if we went backwards and we distributed this or FOILed it or whatever you want to call it, that we would end up with this answer. X times x is x squared, negative 9x and negative 9x and positive 3x combine to make negative 6x. Negative 9 times 3 is negative 27. So you can always check your answer by doing that, multiplying the polynomials like we did on Monday. So I want the rest of this worksheet to be finished by the end of class today and turned in. So it is a long worksheet, it's 27 problems, but you kind of understand this concept of what I'm expecting you to do. This video is only 10 minutes long, so that means you should have 38 minutes left in class to work on this at least, maybe about 30. Okay, I'll also be looking, making sure at the end of the day, I'm going to pick up the actual worksheets from the tray to make sure everybody has done it and everybody was working. So I will be grading these at the end of the day.